Vidak. I have a PhD in physics education, and I'm working at the Faculty of Chemical Engineering and Technology in Zagreb. Today, I will speak about augmented reality technology in education. Augmented reality, we can define it as a real-world context that is dynamically covered by coherent location or context-sensitive virtual information. On this picture, we have some example from the tourism. We have a mobile application that is using GPS coordinates, and user can get some information about hotel, grocery store, restaurants, and transportation. On another picture, we have an example from IKEA, a furniture store. They have a mobile application with 2,000 different furniture items. So you can choose some item and put it in your own room to see how this is looking. Do you like that? Do you want to buy that? Okay. We'll go first from the history of augmented reality. First year, it's 1901. There was The Master Key and Electric Fairy Tale by Frank Baum. It is a novel that was published by Frank Baum, and here he introduced the augmented reality glasses. When people put these glasses on the other people's foreheads, they could see some characteristics of their character. So B for bad or G for good. Then, 1957, Morton Haley constructed the first physical device called Sensorama. People could put their head inside this machine, and they can watch some kind of 3D movies. Okay, in the 1968, Edward Sutherland and Bob Sproul at Harvard University constructed first real device called the Sword of Damocles. It was so heavy that it needed to be attached to the ceiling, but it worked. Graphics were very poor, but they first successfully demonstrated a real augmented reality glasses. Then in 1975, Myron Kruger constructed Video Place. It consists of a few rooms, and people could communicate with each other without some glasses, but only with gesture. So he is using projectors and cameras. In 1991, Pierre Werner constructed digital desk. He used a projector to project the graphics onto the table. He used a calculator, and when you press these virtual buttons on the desk, you can make some calculations on the computer. And this worked for other software. Okay, then in 1992, Henry Fuchs, Mayura, and Oguchi first time demonstrated the augmented reality glasses. They were seeing ultrasound imagery within the patient. So we have pregnant women in that they can see the ultrasound image in real time with their glasses. And in the same year, Rosenberg enhanced operator performance in remote environments. He put some text labels in augmented reality and proved the efficiency of his system. can see a mobile device, electric motor, 3D electric motor is on the top of a real electric motor, and sensors are bringing the data into this application. So user could see if there are some errors and he can correct them. Another example is from the agriculture. There is a mobile application where you can see what is the moisture, the temperature, etc. What things need to be done to have a very successful plant. Then, in this picture, we can see an example from anatomy learning. Student is wearing augmented reality glasses and he is learning about the heart. In the right corner, you can see a teacher. He is teaching his student in the real time. Okay, and fourth picture, we can see augmented reality glasses for personal use. There is an example of the temperature, some flights, and you can schedule some meetings. Okay, I will now talk on a few slides about potentials of augmented reality in physics education. Okay, it is increasing the amount of information about the target phenomenon. Often, students have difficulty with abstraction. Physics can be very abstract. It's hard to visualize lots of equations, etc. And this augmented reality could help students to visualize. Well, we have here 12 life principles for more effective learning. He read hundreds of articles and he included 12 principles that are most effective for learning. Okay, here we can use 4 of them. First, it is multimedia principle, advantage of pictures and words versus only words. Okay. Using augmented reality, we can put static and dynamic multimedia, images, movies, animations, 3D objects in the materials. We can make interactive books. Then spatial principle, advantage of proximity of words and pictures. We can put text near the objects. Let's use the example of the 3D model of the car engine. Okay, we can put different words near the parts so students can easily learn this part. Okay. Here we can see example from astronomy. So the student wears AR glasses and he is learning about trajectory of planets and other stuff from astronomy. And here we can see example from our project where we made interactive materials from the rolling motion. So there is a QR code. Students could download application from the server, and then this QR acts as an image target. And inside the mobile application, this target could run the simulation of the rolling motion. And a similar thing we will do in the workshop. Okay. Second, we are still on the higher principles of learning. Time principle, advantage of simultaneous display of words and pictures. And second principle, preference for custom segments. Okay, here we have custom segments in online learning. So students could use these simulations and learn at their home, learn through online. Okay, what is another potential novelty effect? It has been proven that students like this technology. They are using similar technology life, so they like this technology. And another thing is availability of mobile device. There is no need to invest for new devices. Almost all the students have mobile devices that have enough power to run this kind of technology. Okay, here we can see an example from the physics learning about kinetic theory of gases. And here we can see the learning about the force field of the Earth. And some kinds of augmented reality glasses are used in this example. Okay, now I'll present some results from our review article. We made some research paper. We have read 60 research papers that were indexed in Scopus and area databases, and we have found that most papers were published in the year 2020. Okay, you can see the graph here from 2012 to 2020. At first, there are a small number of articles. Why? We can argue that because of the availability of technology. So mobile devices are now more powerful and can run this kind of technology. Topics. On this graph, we can see which topics were teamed in using this technology. We have electric circuits, astronomy, mechanics and mechanical waves, magnetism, atomic and molecular physics, thermodynamics and heat, electrostatics, radio optics, electromagnetic waves. So, most of the research that we're using this technology were from electric circuits. Okay, why? Probably because this phenomena is very hard to visualize. You know, it's hard to see the electrons. Okay, and when people see electrons, they are very excited. So people like to use it in this kind of talk. Okay, and astronomy is second. Why astronomy? Well, people are fascinated with the planets, the universe, etc. Because it is because these themes, these topics are not in their everyday life. They are very distant. So they like to use that. Okay, advantages. We have group advantages in three groups. First, positive effects on effective learning. Here we have attention, interest, and engagement, general motivation, satisfaction, enjoyment, general attitudes. Then, positive effects on cognitive domain of learning, knowledge gain and transfer, moral depth inquiry, and self-regulated learning, facilitating visual learning, reducing cognitive load, generic thinking skills, reducing test completion time. High accessibility and usability as a third group, ease of use and practicality, low cost, health and environment, and differentiating instruction. Okay. Advantages. We picked up 116 advantages. So, in next slides, I will choose some of them to speak about. Okay, the primary goal of learning is knowledge gain about the target topic. Okay, the most powerful design is pre-test, post-test, experimental design. So, in this kind of design, we have the whole group of students and they are assessed at pre-test. Then groups are divided to experimental group and traditional group. And the experimental group is using augmented reality technology, while traditional group is using traditional tools. And then after that, first and second group gets the post-test. And then scientists are looking at the data, so they have a conclusion. They conclude 90% of students have positive progress compared to traditional treatment. Moderate to great progress. So this technology is really working in education. Yeah, there is a big advantage of using this technology. Okay, the second advantage, motivation. We can define motivation as a process that determines the direction and energization of behavior. Okay, it affects persistence and goal achievement. Increased motivation has been shown due to AR usage. Okay, mostly astronomy. Like I said, we are fascinated with the universe. It is unknown phenomenon. Here we can see an example from astronomy, a mobile device application that is used for learning about planets. Okay. Another advantage, attention, interest, and engagement. Attention makes information available for thought and action, while interest is related to the purpose of performing a certain activity. Okay, it has been proved that augmented reality increases interest and desire to learn. Using AR applications after the regular classes and for other subjects. So students are asking for more AR applications. They want to use them in other subjects, in other sciences, and they want to use these applications at home. Mostly electrodynamics. Well, some of this phenomenon is hard to visualize, and here we can see an example of AR application. We have visualizations of the current and the magnetic field of the battery. Disadvantages. Yeah, we don't have only advantages. There is a cause. Here we have grouped them into two groups. First, negative effect on cognitive domain of learning, increasing extrinsic cognitive load, generic thinking skills, knowledge gain and transfer, and low accessibility and usability. Complexity of use is in this group health and high cost. We have found 25 disadvantages. Okay, first of them, complexity of use and practicality. Well, if we go here, we can see that 70 of them are from this subgroup, complexity of use and practicality. Okay, why? Imperfection of software or higher technology. Lots of bugs. Software, slow software, and image detection failure are most instances. Hardware, camera freezing, and lots of power. They have been found in the wide range of topics. Astronomy, electrodynamics, magnetism, optics, and the nature of light. So, how can we fix them? We need to use latest software and absolutely suitable devices. So, we need to test these applications on the devices we have. Okay. Then, students have reported deficient AR application design. They don't like the AR application design. And professors said more demanding implementation of the teaching process. So, complicated setup for AR environment, they need to connect multiple devices, they need to install additional softwares, print markers, etc. Then, inadequate hardware devices, cameras, are very bad. They are slow, and some augmented reality technology have narrow viewing angle. Okay, we have a wide range of topics from astronomy, electrodynamics, electric circuits, magnetism, mechanics and waves, optics, and nature of light. What's the solution? It is very important to optimize hardware setup and AR tool design. design. So if we are designing AR applications, we need to follow the strict rules. We need to be very careful how we do that. And hardware setup, well, we need to test our AR applications if they are working with the hardware we have. Okay, hardware devices. Mobile devices, Android, some of the researchers didn't specify. We have smart glasses, desktop computer with camera, motion sensor, mobile devices, projectors, others. Okay. We have found usage of these hardware devices on this group. So we can see here the most researchers used mobile devices and Android operating system. Okay, and in some 38 articles use mobile devices. Okay, you have all seen mobile devices, and now we can see some other AR environments. Kinect from Microsoft, it is used for Xbox. It is using the motion sensors. So here we can see an example of playing beach volleyball inside the room. Here, Microsoft HoloLens, it is used by medicine doctors. They are arguing about some image, 3D image of the brain. They are using AR glasses called HoloLens. Meta company has produced the AR glasses for a wide range of purposes. And here we can see a system that is using a camera. This system projects content to the table, and it is using a motion sensor, so you can manipulate this content. Okay, software environments. You need some software to produce augmented reality applications. Okay, what have we found? Most of the researchers didn't specify the environment where, from which their application was produced. Okay, we have Unity 3D and Euphoria, that is known, some other AR toolkit, and only Unity 3D. Why most of the researchers didn't write about their environments? Well, some of their patents, competition, maybe some commercial usage. Okay, but from the free software, they are using Unity 3D and Euphoria. Okay, and in some 18 of them use this environment to produce AR application. Okay, let's say something about this Unity 3D software environment. It can be used to create games, animation, movies, car industry is using that, transportation, architecture, engineering, manufacturing, and construction. So, wide range of topics. It can be used to create 3D, 2D, VR, and AR projects. Languages you need to know are C# and C++. And beautiful thing is, it is free for individual usage. Then, if you want to create augmented reality, you need to use Euphoria SDK. So this is a free plugin for the Unity. Okay, and here in this picture, we can see a scene from the Unity 3D. This is some kind of the shooting game, so it's very complex. Okay. Now on this slide, I will talk about some commercially available AR simulations because not every researcher or teacher can produce AR application. Okay, there are really some commercially available. You can find them on the Google Store, Android, Physics Lab. It is used for teaching about astrophysics, electrical circuits, electromagnetism, then physics AR, Newton's first law, CG, physics AR, it would be used to teach about electromagnetism, and astro realities, lunar probe, it's commercial, and it is used for teaching about the moon. Okay, now I will show you some Gravity AR project that we produced. In this review article, we have learned about best principles of developing AR applications. So, and we made some application. So, here we are using some targets. We have two targets for the stones, and here inside the AR application there are planets. So this application is calculating the force, the gravitational force between them. So you can change the distance. If you move this printing image, you can change the distance between them, and these vectors are changed too. Okay, they are changed with magnitude of the force. And here you can change the mass of the body 1 and body 2 of these planets. Okay, so it is used for students in high school, maybe on the college. With this application, they can understand the force of gravity. They can construct the equation. Okay, and conclusions. We have seen advantages of AR technology, knowledge gain, motivation, interest, satisfaction. We have mapped 160 of them in physics. Disadvantages, we have mapped 25 of them, technical usability and software hardware imperfection. Then you can create AR education applications, but you need to use some programming skills. And if you don't know how to program them, you can use some available solutions that are commercial, probably. And after that, you can produce new examples. How? The best thing is to look about research articles and find some misconceptions and use them as your team. Okay, here we can see an example from economy. We have some script, and these applications is making 3D graphs. Okay, thank you. Questions?
What is the exact difference between virtual reality and augmented reality?
Okay, virtual reality, the world is virtual. You're inside the virtual world. And augmented reality, you have a real physical world and 3D objects inside that world. So, on the top of the physical world.
Yeah, I was just wondering if you had any thought on which one do you think virtual reality versus augmented reality is going to become like more usable, say like in the home or in the university or whatever. Is one going to outcompete the other, or is it just a matter of each one has different applications?
Yeah, I think each one is having different applications. So, augmented reality have the easier usage. So students have the mobile phones and they can easily use them. But for virtual reality, you need to have the goggles. Yeah, so they are expensive, and etc. And it is harder to create virtual worlds. It's expensive. AR applications are expensive because you need more developers, and etc.
Do you think that like augmented reality then is just like a stepping stone to ultimately everything be virtual reality, or do you still see like in the future places for both?
Well, at first there is place for both, but probably with increased power in the current devices, virtual worlds will be, how to say, they will be in the game.
Yeah.